Hello and welcome to this video on solving exponential equations using logarithms. We are going to do a review example first because this is an example of an exponential equation with both exponential forms on both sides of the equal sign, as well as having a possibility of creating same bases for these exponential forms. If we have a base of 4 and a base of 8, a 2 can be raised to a power to get both of those two numbers. So we're going to replace the 4 and the 8 with 2 to a power that would give us that result. So I can replace the 4 with 2 squared and the 8 with 2 cubed. And then the rest of the problem would then stay the same. So I would have an x as an exponent over here still, and I would have an x minus 1 as an exponent on the right side. Now I have to distribute the exponents by multiplying. Since power to a power, you multiply those powers, those exponents. And so you would basically be doing 2 times x and 3 times x and minus 1. And that would give me 2 to the 2x, and that would be equal to 2 to the power of 3x minus 1. Now that we have the same base, I don't need the 2's here anymore, since I know if those are both 2's, the exponents have to be equal. And I would know that 2x is going to be equal to 3x minus 3. And if I solve this equation for x by subtracting 3x and then dividing by negative 1, that would mean my answer is equal to 3. And that would have finished up that problem. In our next examples, we will be looking at problems that are exponential equations without common bases. So we can scroll down and look at our steps first. So we have some important things here is that we're going to try basically looking at equations where we're going to use a common logarithm. Remember that common logarithms will just be log of an input of some kind, but the base of those logarithms, they are going to end up being a default as a 10. So that's a very important point to keep in mind. And then we're going to use the power property of logarithms to move exponents to the front of a logarithm we have, and then solve for x at the end. And we're going to kind of think of these in terms of logarithms instead of getting decimals for each and every part, as that allows us to avoid some errors we might encounter with rounding in our different problems that we're working on. So make sure to have these notes copied down before we move on to these next examples. We are now going to go through some examples of solving exponential equations, and we will kind of take a look through the steps together before trying some from the beginning. In number 1, we have 5 to the power of x is equal to 120. You'll notice that I can't raise 5 to a power and get 120. Those two numbers don't have any common bases like our original example problem did. So these are already different. Our steps are going to follow in the following order pretty much each time with some small variations. So we're going to do the logarithm on both sides. So I could draw in some parentheses here if I wanted to. So I took the log of both sides of the equation, and then the x is going into the front because that's what the power rule is saying to do. Exponents are powers inside of the logarithm can go in front and be a coefficient like you see in blue right beneath it. Once we're at step 2 here, after moving the x, we can divide by log of 5, and like before we could put in the parentheses here and we're just dividing by that whole logarithm. And that means we can cross out that whole part right there. So I cross out these two logarithms. So I just have an x on the left side of that problem. And then I could get a calculator and do log of 120 divided by log of 5. And that's just as simple as using the log button right on your calculator screen. We can check the calculator part of problem number 1 by using my computer calculator here. I can do log button 120, close parentheses, divided by log of 5, close parentheses, and that makes it so my answer is 2.97. That matches up. If we do 5 to that answer power, we would get 120, so we know we did it right. Number 2 is essentially a carbon copy of number 1, so feel free to pause the video, take it down as another example for your notes. But number 3 is the next problem that is important for us to cover, in that you have an x minus 4 right here that's going to change the end result of our problem. So what we basically have to do is move the whole x plus x minus 4 part to the front of this and become its coefficient. Important to keep it in parentheses. And then we do the same as before, divide by the log on this side to get x by itself on both sides. You see how the log of 2 is being divided into both sides. And then I have this logarithm fraction, and you're adding 4 to that logarithm. So let's grab our calculator again, and we want to see if we can check this answer for our logarithm here. So the way that I would suggest putting it into your calculator would be to put log of 82.1 divided by log of 2, and then hit enter, and then plus 4 right away to use that answer, and it gives you a result that we wanted. So that means that I can do 2 to the power of that answer minus 4 should give me 82.1, and it does in fact do that. These last two problems are both interesting problems in and of themselves. Number 4 is not very commonly seen, where you see x squared being an exponent in an exponential problem. So you feel free to take down those notes, but a more common problem to see would be number 5. It is similar to number 3 that we talked about before, but in this problem you have, instead of x minus 4, you have a 2w plus 1 as an exponent. So most of the problem is similar to 3, that the first step is the same. Put the 2w plus 1 in the front of the problem. And so you have that done right here. And then you are continuing by just dividing by this log of 5 on both sides. And that would lead you to having log of 17 divided by log of 5 on the right side. So you'd have to subtract 1 first. You can see that in blue right underneath. And then when you are dividing by 2, you're basically dividing by 2 into everything. So a way you could write that to make it a little easier to see, and the way I'd recommend it, is that you kind of basically have like dividing by 2 into each part, so that 1 would just be minus 1/2 on the end. So that's easy. But this logarithm fraction is when you're dividing it by 2, you're actually multiplying by 1/2. So if you look at this log fraction right here, half of that would be log of 17 on the top divided by 2 times log of 5 on the bottom. It's kind of like you multiply that original fraction by 1/2 in order to make it work the way you need it to for the problem. And those are all some great examples of solving exponential equations using logarithms, specifically base 10 or common logarithms. We are now going to solve some exponential equations, and we are going to work on these 3 examples. So before we try each one, you should try to see if you can solve for the given variable before we work through it together to check your understanding. For starters, we're going to work on number 1. So pause the video for a moment, try see if you can solve for n, given the equation is 6 to the power of n is equal to 99. Now that you've tried it, the first thing we're going to do is that we need to think about, well, can I make 6 into 99 using a power? Well, that answer is definitely no. So I would need to take the logarithm of both sides. So that would look like the log of 6 to the power of n is going to equal the log of 99. I'm going to do that 99 in black. We also remember that we're using common logarithms, so you could write the little tens in if you like, or to leave them out, that is up to you. The next thing we will do would be to move the n to the front using the power property of logarithms, so we would have an n in the front there. So now our equation that we're working with is n times the log of 6 is equal to the log of 99. And the last step that we need to do would be to divide by log of 6 on each side. And that would basically give us our result, that n is, once these are crossed off, is equal to the log of 99 equal to divided by the log of 6. And we can grab our calculator to get an approximation for that answer. So let's do that. We can do the log of 99 divided by log of 6, and we get an answer of 2.56, about 2.56 for n. So we got our first problem all done. Let's divide it out there. So in problem number 2, it is just like the one we just did, and you can kind of see some similarities to the ones from earlier in the video where we had a variable as an exponent. There was a number times the variable. So we got to think of this as if this was like 5y equals 20, the first thing we would do would be divide by 5. So we have to do that first. Easy enough. Now we've got 6 to the power of 3m is equal to 4. So that's a little bit easier of an equation that we're more familiar with from earlier. So now we have to do the log of both sides. And we can fill in the 4 right here and the 6 to the 3m on the left side, and we got them equal to each other. Then we do product property. The 3m is going to the front. So we have 3m log of 6 equals the log of 4. Then we're going to divide both sides by log of 6. So that means that we have 3m is equal to log of 4 divided by log of 6. And we're almost done. So now we just got to divide by 3 or multiply by 1/3, however you need to think of it. So that would mean there would be kind of like 1/3 times this logarithm fraction from the step before. And that would just mean that we are just putting that 3 right there into this fraction. And that approximately equals, we would do 1/3 times the log of 4 divided by the log of 6 in parentheses. And 0.257 ends up being our answer for m point, and we'll round that to 0.26. And the other way to write that we kind of talked about before would be log of 4 over 3 times the log of 6. And that would kind of cover example number 2 here. So lastly, let's look at number 3, where we have a little bit of going on outside of the exponential part. So we got to get rid of that 3. Obviously, we're going to subtract 3 from both sides. So 9 to the n plus 10 would be equal to 78. No way we're getting 9 to be 78. That's not a multiple of 9. So we want to write it as the log of both sides and once we have the log of both sides, the n plus 10 is moving to the front. Make sure you use parentheses for this part up front. And we get a result like that. N plus 10 in parentheses times log of 9 equals log of 78. And then I'm going to divide by this log of 9 right here. That would leave me with n plus 10 alone. And then we got log of 78 over log of 9. And so we have almost the answer. We just got to get rid of this 10 right here by subtracting 10. N equals log of 78 log of 9 right there. And so we have a result that we would just need to subtract 10 from to get the answer. And that would equal about, let's check our calculator. If we did the log of 78 divided by the log of 9 and then subtracted 10, we would get negative 8.017. Negative 8.017. And that covers solving all of the exponential equations that you could come across when it comes to exponential equations where you need a logarithm to solve them. And these are very applicable to the real world, as you can imagine having to solve an exponential model, kind of like what number 5 looks like, where your a and your b and your exponent are very common to see in exponential equations. And that is all for today's video.